Okay, so this is yet another week, and I didn't do anything, so I have nothing to report. So I'm just going to turn it over to Al.
Um, so I spent a little bit of time, well, a lot of bit of time on the 3DR radios because I'm using 3DR radios to get correction data from the base station GPS to the rover. And a couple of weeks ago, also I was messing around with a data logger using Google Sheets, and I thought, well, in that particular scenario, I was using Wi-Fi to get the data off of the sensor back into something usable. So I thought, well, I'll spend a little bit of time understanding these 3DR radios a little bit more. So what I simply did was got, um, a 3DR radio, and there's multiple versions. There's some with just a USB connector. There's some with the USB, like this one, a USB connector, and I don't know if that's a JST pin, a DST pin. I don't know those names, those pins. And there's some with, this happens to have um, 6 outputs on the, if you do use the wiring harness, others have 4. So anyway, there's some variability in those 3DR radios.
Just a minor point right there. Be careful on those cables because when you get it, the two cables, the two ends of that are wired differently. One is wired to plug into the radio, and the other end is wired to plug into that whatever that controller is that you're supposed to come with it. So always make sure you verify which pins are which before you start hooking it up.
Yeah,
Don't expect that to be a one-to-one cable because I think I did up front, and then I finally realized, oh no, it's different. So it might even have a different number of pins on it. Did you I say something so it'll switch to you?
um, this is a 6-pin wiring harness.
And did you cut the other end off, or did you use their cable? Yeah, that end there. Yeah,
I cut the end off.
yeah, that's what I did too. I just redid that cable because you can't really do anything with the part that plugs into the radio. You have to use that part because otherwise you're gonna have to make your own, and I don't know how to do that. So yeah, that's exactly what I did too. Okay, I just wanted to point that out.
And all I did was, mounted an Arduino Nano, and one is this happens to be the receiver, and then I had a similar one that I just made as the sender. First got it to talk to each other, just being hardwired, and then got the radio working. And I just wanted to point out a couple of things on getting the radio to work. There, as Jeff mentioned before, there's different ways to program these. You can actually just log into them via PuTTY. Hold on, let me share my screen. And I found logging into them via PuTTY, really simple and really useful if I just wanted to know what the settings were. There's also inside of Mission Planner, which is an Ardu Pilot, Ardu Rover, you know, um, multi-purpose piece of software. You can configure these things in that software, and what you're looking at is a screen print showing various data elements inside of the configuration. I'll just start with the version. I had multiple versions on. I have, I don't know, 6 or 7 of these things floating around, and 2 of them weren't working, and blah blah blah. So I cleaned them all up. I got them all on the same firmware. This Mission Planner software lets you post or push firmware to them. So 2.2 is evidently the latest that Mission Planner sees. The baud rate, there's 2 speeds that you have to, that I had to fiddle with. One is the baud rate for the serial connection, and one is the air speed, which the airspeed is the actual speed at which data is being transmitted between the two radios. The baud rate is, as you might guess, the speed going between, say, your laptop or microcontroller and the serial connector on the radio when you're programming it or getting data from the radio. Net ID is a unique identifier for the series of radios. So 25 is just an arbitrary number. Transmit power, I'm not going to talk about that. 20, I think, is the highest. And then this MAVLink, it says MAVLink there, but this drop down, and this is just a screen print, so I don't have the drop down data, but there was 3 on there: raw data, MAVLink, and low latency. And because I was just using Arduino code to pass data back and forth and not trying to do, radio control stuff, I just used raw data. And that was getting all of those things organized between the two. I mean, it takes 5 minutes, but if you mess it up, it's not going to work. Like the net ID has to be right, the baud rates have to be right, and this MAVLink setting has to be the same on both radios. And so I was able to get that to work without any issue. I mean, let me show the sender software first. I was just sending a simple message just to get it to work. And so the message was just hello with a /n, which was that a Terminator? I forgot the exact language to use. So I was sending the 5 bytes plus 1 byte for that. And so I was writing to in my case, I was using the hardware UART because I had tried the software UART, and that might work, but I couldn't get it to work. Probably maybe a wiring issue or something. So I just used the hardware UART, and then I blinked the LED. So it just sits there and sends this stuff. And then over on the receiving side, which is what this is, it's just looking for, is there anything on the serial? And it pulls down the 6 I'm going to say characters, but I don't, probably more appropriate to say 6 bytes. And so anyway, I got that all to work, and it was working fine. And then I had a few weeks ago talked about a level shifter, and I use an ESP32, and its CPU runs at 3.3 volts. So according to this is Random Nerd Tutorials. I like those guys. And he says, hey, you can, if you've got, like in this case, he was going to send from an Arduino to an ESP8266, which again is operating at 3.3. He said you need to shift the voltage, and there's 2 ways to do it: a voltage divider using a couple of resistors, or getting one of these bidirectional converters, which I've gotten. And so I put the board together to hold the ESP32 and the logic level, and soldered the wires on how I think it should work, but it's not working yet. And I had my trusty I don't have an oscilloscope. What I do have is a auto range multimeter, and was trying to figure out why in the world that wasn't working. So that's and the connection again of all of this back to the GPS is I use these radios to get the correction data. Currently, it works fine, but my GPSs are 5 volts. I have a faulty GPS that I haven't fixed yet, and have contacted the supplier. But if that doesn't end up working, I might end up having to buy another GPS. It might be 3.3 volts. And so I might need to figure out this logic level stuff, which is sort of, I've got a couple of reasons why I'm spending time on this, but that's where I'm at now. The debugging.
A few points on that. Number one, check your radio and see if the logic pins really are 5 volts as opposed to 3.3 volts. I thought the transmit and receive on those was 3.3 volts. And it could be if you go out to that web page where they say it's the SIK advanced programming or something, that somewhere it should tell you what the logic levels are supposed to be on that.
Is that upside down? Yeah, it might be it might give can you see that V5 on there?
Yeah, but
Or
that's
is
the
it
power,
upside?
that's the power supply. That's not the logic level transmit and receive. So I'm thinking you give it 5 volts in ground to make it run, and then I was thinking the transmit and receive are 3.3 volt. I don't know that for a fact, but I was thinking that was the case.
I'll be darned. So I
And
don't need this plug.
since you just pulled out your voltmeter, next time you have it fired up, check the transmit pin and see if it's at 3.3 or 5 volts. And that should tell you. And the second point is, any more on that before we move on?
No, I can do that.
But that, anytime you're playing with this stuff, check it and see what it is. Because, even the little FTDI connectors, you get those, and some of them will say they'll put out 5 volts, but then the transmit and receive will be at 3.3. And, back when they started all this stuff, it was real confusing. And then they got smart. They put a little jumper on the board. If you move the jumper, I think it changes both the logic levels and it changes the voltage that it puts out to power things. And sometimes those FTDI things always put out 5 volts, but you can switch the logic levels to either by just moving a jumper on the things. Sometimes some of the boards you might cut something and resolder something to get it to work. Some of the modern ones just have a little, the shorting blocks. So you put it in one position or the other to get your logic levels at the right point.
Interesting.
Now, the other point was you were saying your GPS runs at 5 volts. Well, technically, I believe on yours, you've got 3 RS-232 connectors coming off that run at, plus or minus 5 or plus or minus 12 or whatever. And you put that little FTDI type adapter on there. That's what's going to control whether it's 5 volt logic or a 3.3 volt logic. So it's really not your GPS itself. It's that little adapter board that you have. And again, that little adapter board may or may not have that jumper on to change the voltages. Does that make sense?
Yes. And because I have not put a multimeter on it, to see what it returns. I have. Go ahead.
And I believe, the idle state of the logic level serial should be at the high state. So, if you just measure that, the transmit pin should be at either 5 volts or 3.3 volts. And the receive pin, I don't know if you'll see a voltage or it'll look like 0 volts or whatever. It depends how they built the modules. So, but that's a quick way to check, just check the voltage in that. Or if you can go look up all the specs on these radios, they should tell you, hopefully they would tell you somewhere what that is. And I looked at all this one time and I hooked my stuff up and I don't remember anymore what I had to do to get it to work, but I usually try to track that down fairly well so I don't risk blowing up my expensive parts. And those radios aren't very expensive, but you plug it into really expensive things.
And so I think you answered a question that I did have in the back of my head, and that was, my multimeter only operates at a certain speed, and but you said the transmit pin, to your recollection, is always high. So
if you're not sending data, it should always be high.
yeah.
So your speed on your multimeter has to be 0. As long as they can do 0, then you're okay. But yeah, that should tell you.
Cool.
you don't want to measure it while sending it data because you're gonna get some weird average of what what the data is doing. But if it's you're not sending anything, if it's just sitting there with not transmitting data, then it should stay at whatever the high voltage is.
Cool. Yeah, so fiddling around with that is what I'm doing, and so that's the front side of that logic level, and this is the back side, and so I've got there's a high side on voltage and a low side on voltage, but if the radio is operating at 3.3 volts on the signal line, I might not even need it. That's what's going on here.
Back to that back to that level translator that you have. The audio is doing something funny again, but on that little board, I have never actually used one of those, but I've seen people complain about them. I think they're originally designed to use on I2C interface, and so they expect the input signal to either be high normally or low normally, and but I'm thinking it should work for what you're trying to do. And since the guy on Nerd Tutorials says if he says it will work for serial data, then it will probably work. It's just that just the way they've built that thing, I've never trusted those. And does he say specifically down there when he's talking about that level converter, or did he just simply say it will convert back and forth? Does he say it's for I2C or for serial or
Yeah, I
so?
was just looking back to see slow signals, but not reliable. Recommended method to level shift signals that require speed communication, serial at a high baud rate, I2C, etc.
Because I think the way those work is, both sides are at whatever voltage they want. If you pull one side low, then that pulls the other side low. So I think maybe those should work with like logic level serial. But you can play with it, see if you can get it to work. And does he give a little diagram down below how to wire it up so we can compare it against what you did?
No, he doesn't. I saw that there's others that
You could go right to SparkFun and look that board up and see if they
yeah,
give you suggestions on that.
from another site that I don't remember where. I mean, in the middle there's a low voltage pin, there's a ground, and then on the high side there's a high voltage pin and a ground. So ostensibly, well, I'll just tell you, I'm connecting 5 volts on the high side, 3.3 on the low, ground from the ESP32, ground from the power in.
Are the grounds tied together?
They are.
Okay. That's
Well, I
that's
think
what
they
I would
are.
do. Yeah.
Um, and then, I'm just using one channel for just to start with as a sender. I'm just using one channel. But it's not working. So, and these radios have a blinking, one LED that shows that it's connected to another radio, and then there's a little red LED inside whenever it transmits. So it connects to the other radio and joins up, and so the green LED goes solid, but the red LED for transmit never um, illuminates, showing that it's actually transmitting any data. So I'm not getting any data out. Simple problem. Anyway, that's all I had. You said you wanted to talk about did you want to talk about the Google Sheets data logger?
If you just briefly want to go over that. And I just before the meeting, I went and looked at your code and saw, well, basically it looks like it's an Arduino type uh, compiler that you're using because you've got the standard setup and the loop. And then it says, I saw under setup, you do uh, serial begin, then you do like a radio begin, and then under loop, you read up your sensors, and then there's just a chunk of code that says something like create an HTTP instance, and then you just build a big long command line, and it looks like just one line you call to actually send the data. So I'm just curious what your thoughts on this whole thing were, and how hard it was to get it to work, and how well does it work?
Um,
And the reason I ask that is because every once in a while I think, if I could log this in my house, it would be real handy. But then I don't want to pull out an Arduino and build up a whole Arduino, to read a couple of pins and have it try to connect to a server somewhere. And it just seems like this would be a quick, easy way to do that. If you just have an ESP32 laying around, you can just hook it up and log whatever you want. So I just
yeah, how easy was it? Well, pretty easy. There was a guy out there that had a YouTube video, and he was logging GPS coordinates, and so that's what I started with. Although I didn't actually use GPS coordinates, but I started with his code, and then just there in this one gist file. There's two parts to it. The top part is what runs on the ESP32, and then there's a comment here. This is the code that runs in the Google Sheet, and so it's effectively yeah. So this comment, you're effectively building this URL, and the variables, these names are important, and the values are your actual values. And so if there were 5 variables, which in this there actually are, but I didn't update the comment, there would just be the variable name and the value, and on and on and on. And so from a web perspective, you're creating this URL, I'm going to say posting this URL. I don't know if I get those verbs confused sometimes. And then the Google Sheet is taking that URL and then parsing that, probably is a better word, parsing that. And so that's why this is the code again down here that runs on the Google Sheet, and it's parsing whatever data that you're sending it based on the variable names that you've given it. So to answer your question, once you have somebody to follow, it's pretty simple. The other thing you do is when you create let's just go see if my battery is still running, because the ESP is powered by a battery, and I wanted to see how long it looks like it's still running. If there's current data there, then it's like a Mars rover. It's still alive. Yeah, it's still alive. And so the macro, you get to the macro by going to data or tools. Where is it? Extensions, app script.
So is Google Sheets just an actual web page? So if you just go to the web page, everything shows up, or is it something that you have to like log in to get to this stuff? In other words, is this public data, or is it takes slightly more complicated than that to view it?
If you have a Google account, you can create a sheet and um, you set security, and to make it simple, I just said anyone can access that. Um, so I think that answers your question. It takes a
Yeah.
Google account, which is not, obviously not anonymous. And once you have a Google account, anybody can create a sheet in this extension. And they say, as long as you don't go crazy, they don't charge you for the compute time. And so I think, you probably, if you were doing 1 Hertz updates and passing a whole bunch of data, you'd probably get a bill from these guys. But um, for this level of usage, I'm not getting a bill from them, because this actually runs in their hosting service. Does that make sense?
Yes. It does seem like, eventually if you're going to be doing this stuff, you should figure out how to create your own server. And then, instead of handing everything off to the cloud like everybody likes to do, if you create your own server and give it access, so anywhere in the world it could write to your server at your house, and you would maintain all the data. But for
Yeah.
something quick and dirty, this is real handy to be able to do that. Because yeah, if I was going to just monitor temperatures in my house, I wouldn't care. If they have my data, I guess. So
And the other thing I was just going to point out is, whenever you create a sheet, you're going to get, they're going to assign this, whatever it is, 30-character identifier for that sheet. That is, you know, um, that then gets used in these commands to say, this is the sheet that I want you to update, both at the ESP32 as well as the uh, the you get this thing called a deployment ID, which is unique to your sheet. Put in your SSID and your password so that the ESP32 can access Wi-Fi, because that's what that's how I'm getting the data off of the ESP32. I don't have this correct yet, because I thought it was just going to sleep 10 minutes. It's sleeping an hour. That's okay.
huh.
The setup BMP 180 sensor needs some setup. The temperature sensor needs some setup. And the loop is just to get temperature from the BMP, temperature from the DS18B20. There's actually 2 temperatures there. Humidity off of something called a DHT11. Calculate the heat index based on the DHT11, and then get the Wi-Fi signal strength. And then it goes into that function with all that data and builds the URL that is actually sent with that command. The return code, I was getting some goofiness on the return code, so OK or 302 for me was good. 302 is a redirection message. Not exactly sure why I was getting a redirection message, but the data was being updated. And I put 2 different functions in there to try to see if I could get rid of that redirection, but I couldn't. And that's it. So if you change sensors or change data, certainly you can start with this as a shell. And then this is the code again that's running on this spreadsheet, and it's just adding a new row and appending the data that I've chosen to append. You could do other things like create multiple sheets in one, I'll call it workbook. This is just one sheet, one workbook. So, I mean, you could get more fancy with it, but it was freezing in Texas and I was trying to track just how freezing it was. Um, and that's what I came up with. So it's on GIST, and Jeff posted the link.
What's that about posting a link?
To the GIST, I said you updated the video, I think, with the GIST.
Yeah, I edited the actual description and put in the link to that. Let's see. What did you just post in chat? Does that get you to that page where you can see the results? I tried to log in and it's getting cranky because it doesn't like the way I do things. So let me try this here.
Google Sheet.
That says Google Sheets, you need access, request access, blah, blah, blah. Oh, yeah, anyway, here, let's see what this does. I'll say request access and see if you get a message saying that I'm trying to break into your account here. So that may or may not pop up on your email. Then I'm trying to break in.
Yeah, it showed up on my phone. Do you want to be in? And I just press share. So
if I do a reload, yeah, I can see stuff here. And let's see. So we got BMP temperature. Well, it's awfully warm in Texas.
yeah,
other temperatures 70 degrees, 70 degrees.
Well, not all of those are the outside temperature though. So
yeah, it was supposed to get up to almost up to 45 or 50 today. I think it was up to 50 yesterday here, which it was kind of surprising. So what I was doing back when I was playing with this kind of stuff, I had a Raspberry Pi. I used the original Raspberry Pi because it didn't take anything special. And I had 3 of those, what are they? The DS, whatever that single wire temperature sensor. I had 3 of those hooked up. So I had one stuck out the window to get the outside temperature, one just laying on a chair covered up to keep the air from blowing on it. That gave me the inside temperature. And then I had one hanging over the edge on top of a register on the floor. So every time the furnace would run, then I'd go look at the plots. I'd get these spikes in there so I could tell, when the furnace turned off and then when it turned on and then when it turned off. So as the temperature outside would drop, you'd see the here's where the furnace runs. As the outside temperature comes up, then they get closer together. So you get more and more would show up as the thing would run. And I started that, and I started playing with it. And I one day after about two or 3 years, I thought, I wonder if that's still working. I logged into it. It turns out it had died like a week before I just logged in. So apparently I had a power glitch or something. And I didn't think to go into the thing and say when the Raspberry Pi reboots to automatically start this program, or it would have picked up and kept right on running. So
that's funny.
The biggest thing I got out of that was it's amazing that a Raspberry Pi will run for that long and not have any problems.
Yeah,
so that was great. And then the fact it did record all the temperatures. So somewhere I've got, several years of temperatures so it would have gone through, the fall, the winter and the spring and all that stuff. So I could, tell what the temperatures are doing. And then once it gets up to the point where I turn my furnace off, then I quit getting the little furnace spikes in there. So it's just going to follow whatever the internal temperature is. Another thing I noticed at that point, the one I had stuck out the window, it was real sensitive. The wind would blow a little bit So what I did to give it more thermal mass, I got a little plastic bottle that I either bought it at the surplus store or something that it might have been one of those little bottles you get at the you stay at a hotel. They give you these little fancy bottles of like shampoo or something. So it was a tall, skinny plastic bottle. I just dumped that out and rinsed it out, and then strapped that side of my house with a conduit clamp and filled it with olive oil, and then stuck the sensor down in that, and that calms it down completely. So it gives you so you get the average outside temperature. You do want to make sure the sun doesn't shine on that because I had that problem too. The sun would come up in the morning and the thing the temperature would come up, and then as soon as it go in the shade, which it was only like half an hour or something, you could see that happening too every morning. But
Neat.
it all seemed to work. And
Yeah, when I left last, I just stuck it on top of my refrigerator in the garage and put one in the freezer and one in the refrigerator, and then there's an ambient temperature there too, so I have those three temperatures plus the humidity in the garage and barometric pressure and whatnot.
just another minor point here. Depending how you're getting your internet, does your internet continue to work if you lose power to your house? Or have you ever checked that?
Um, it will go out at some point if there's a small UPS, but it will go out if the internet, it is out for an extended period of time.
What is it you're using there? Is that like a satellite thing or a phone line or
It's between those two. It's a radio. Um, there's an antenna about an 8.5 by 12 size antenna that's up in the air 30 feet, and it's pointed to a tower that's a couple miles away. So it's it's sort of like a microwave, but I don't think they operate at microwave uh, frequencies.
okay? And for anybody else watching this, in case you're curious, I found out that DSL, which runs over the phone lines, as long as you power your box at home, you will continue to get internet because your two wires on your phone line run directly to the phone office, and they're all have battery backup. They've had battery backup for 100 years, however long the phones have been installed. And I switched from that to fiber optic, and it turns out apparently from my house I've got a fiber that goes out of my house and goes all the way down like a half a mile away to a building. And apparently they have battery backup on all their stuff. They probably have battery backup which switches to a diesel generator. Because last time my power went out, it was out for a couple hours. Somebody had knocked over a power pole or something. I thought, hey, this is my chance to check that. That's the first time I had a chance. So I went upstairs and drug my UPS downstairs and plugged my fiber optic box. And here's my so there's what my fiber optic box looks like. It bolted to the wall, and then over here is I brought my Wi-Fi router down and hooked up, and there's my UPS down there. And by plugging all that stuff together, I was able to get the thing powered up, and I did have internet while the power was off. So at least the fiber optic stuff, and it may depend on the company you go with, but those will work. Now, if you've got, say, cable TV modem, those probably will not run because the cable TV company doesn't really care. All their infrastructure they put in. You can have power in your house, but I think they have like amplifiers on the poles out there, and if they lose power, I assume all that goes out. So maybe somebody has cable internet could report back to us sometime if that works or not. If you have something like the Starlink and all these fancy things like that, uh, probably those will work because the satellites aren't going to go away as long as you got power on your box in your house. It could probably still see the satellites. And then Al's got something else that's some kind of a radio link that probably if it's going like to a cell tower, because all the cell phones continue to work when the power goes off too. So again, being a derivative of the phone company, that stuff probably all continues to work also. So just in case anybody's curious, that's what I've figured out, and that's the reasoning I've come up with on all this stuff. So that's all I got to say about that.
I'm good.
Let's see. So anything else?
Not for recording.
Okay.